Now we will look at more identities that will help us if we are adding or subtracting angles. So let's start with a warm-up. So it appears that these might be related. Let's take a look. If we look at the sine of pi over 3, we obtain the square root of 3 over 2. If we take the sine of pi over 6, we get 1/2. So the sine of pi over 3 plus the sine of pi over 6 is root 3 plus 1 over 2. In part B, we have the sine of the sum of pi over 3 and pi over 6. The question is this going to be the same thing that we just obtained in part A? Can we just take the sine of pi over 3, take the sine of pi over 6, and add those? Well, let's follow the order of operations. If we have pi over 3 plus pi over 6, we could get a common denominator of 6, and that would be 2 pi over 6 plus pi over 6. And the sine of that angle would be the sine of 3 pi over 6. But 3 pi over 6 is pi over 2. And what's the sine of pi over 2? 1. So clearly, these are not the same. So you might want to make a little note that the sine of alpha plus beta is not the same as sine of alpha plus the sine of beta. This is a common mistake that a calculus student would make, but you cannot split up an angle like that. So what can we do? Here we have 6 identities, but I'll try my best to collapse these down to 3 and give you some mnemonic devices. So in the first, we have our sum and difference formulas for sine. So what is a trick to helping us here? You may notice that if we want to find the sine of alpha plus beta, we have this pattern of sine, cosine, cosine, sine, and the sign is the same. We have a positive, we have a positive. Here we have sine, cosine, cosine, sine, and the sign remains the same. So there's a good little chant for you there that if you have sine of a sum or a difference, you're dealing with sine, cosine, cosine, sine, keep the sign. Whereas if we're dealing with cosine of a sum or a cosine of a difference, we have cosine, cosine, sine, sine, but now we switch from positive to negative or from negative to positive. So cosine, cosine, sine, sine, change the sign. So for sine we have sine, cosine, cosine, sine, keep the sign. For cosine we have cosine, cosine, sine, sine, change the sign. Now, for tangent, I don't have a clever mnemonic, but you will notice that in the numerator, we keep the sign. In the denominator, we change the sign. And that might be helpful whenever you think of the fact that tangent of theta is sine of theta over cosine of theta. And so for sine, you keep the sign. For cosine, you change the sign. But at the end of all this, you do need to memorize these 6 identities. They will become incredibly important in the next section and later sections. So how can we apply these identities? So here we have the sine of 7 pi over 12. Let's first think about 7 pi over 12. It is not one of the angles that we are supposed to know, but can we rewrite it so that it's a sum or a difference of angles that we do know? So I'm going to keep this with the denominator of 12. Can we put in a numerator that will add to 7 but reduce so that each fraction will be a known angle to us? So for example, if we try 2 pi over 12 plus 5 pi over 12, 2 pi over 12 is pi over 6, which is known to us. That's good. But 5 pi over 12 doesn't. So that's not it. But if we switch to 3 pi over 12 plus 4 pi over 12, you'll notice that 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3. So those are angles known to us. So we can go ahead and write sine of 7 pi over 12 is equal to the sine of 3 pi over 12 plus 4 pi over 12. And that's the same thing as the sine of pi over 4 plus pi over 3. And now we can go ahead and use our identity that we've just learned. Sine of pi over 4, cosine of pi over 3, cosine of pi over 4, sine of pi over 3. So we have sine, cosine, cosine, sine. Keep the sine. And sine of pi over 4 is root 2 over 2. Cosine of pi over 3 is 1/2, plus cosine of pi over 4 is root 2 over 2, and sine of pi over 3 is root 3 over 2. So we have the square root of 2 over 4 plus the square root of 6 over 4. These have a common denominator, so we can go ahead and add, and we have the square root of 2 plus the square root of 6 all over 4. Now let's look at cosine of pi over 12. So for pi over 12, let's go ahead and write with denominators of 12. And because the numerator is 1 pi, we will probably have to subtract. So what could we do? Let's try 4 pi minus 3 pi. That will give us 1 pi over 12. And therefore, if we look at each one of these fractions, 4 pi over 12 is pi over 3. 3 pi over 12 is pi over 4. So this will work. So cosine of pi over 12 equals cosine of, now 4 pi over 12 is pi over 3 minus 3 pi over 12 is pi over 4. We have cosine of pi over 3, cosine pi over 4, sine pi over 3, sine pi over 4. So we have cosine, cosine, sine, sine, change the sign. Cosine of pi over 3 is 1/2. Cosine of pi over 4 is root 2 over 2. Plus sine of pi over 3 is root 3 over 2. Sine of pi over 4 is root 2 over 2. So we have root 2 over 4 plus root 6 over 4. So we have root 2 plus root 6 over 4. So here we have an example that's a tangent function, and we also have degrees. So negative 15 degrees is equal to 30 degrees minus 45 degrees. So the tangent of negative 15 degrees is equal to tangent of 30 degrees minus 45 degrees. And the difference formula for tangent is tangent of 30 degrees minus the tangent of 45 degrees over 1 plus the product of those two, tangent of 30 degrees and tangent of 45 degrees. Tangent of 30 degrees is the square root of 3. The tangent of 45 degrees is 1. So the denominator will be 1 plus the square root of 3 times 1. And so this is the square root of 3 minus 1 over 1 plus the square root of 3. But this is not an acceptable answer because the denominator is not rationalized. So let's rationalize the denominator by multiplying by the conjugate of the denominator. So now if we FOIL out the numerator, we have the square root of 3 minus, and now root 3 times root 3 is 3 minus 1 plus the square root of 3. The denominator, because we're multiplying a number by its conjugate, will act like a difference of squares. So we will have 1 minus 3. You could FOIL that out and see that if you're not so clear on that. Now simplifying the numerator, that gives us 2 square roots of 3 minus 4 over negative 2. And now if I factor out a 2 from the numerator, I can cancel, and now we have the square root of 3 minus 2 over negative 1. But if we divide something by negative 1, we end up with its opposite. So we will get negative root 3 plus 2.